Joining me today. Today we're going to be exploring a geometric task involving transformations with the awesome online and free tool GeoGebra. And so the standards that we are covering today fall under the Common Core Standard Math 8, describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates. Notice rotations and reflections are highlighted specifically. Those are what we're dealing with during this task. And under the North Carolina Standard Course of Study for Math 2, falls under experiment with transformations in the plane, including representing them, and given a geometric figure and a rigid motion, find the image of the figure. Given a geometric figure and its image, specify a rigid motion or a sequence of rigid motions that will transform the pre-image to its image. So our task actually has multiple parts. And I'll go through them all, but then we're going to break it down and do it part by part. So first we're going to construct an irregular polygon. Then we're going to find the image under a 180-degree rotation. Then we're going to find another image under a reflection of that polygon with the hope of comparing these two images and to see if they can correspond to each other, and we'll explain. So first, it asked me to construct an irregular polygon and label its vertices. So I'm going to come over here. Notice I'm on my coordinate plane and I've got my geometry tools open. So I'm going to go down because it asked me to do a polygon and go under More. And here is my polygon tool. I'm going to click on that and I'm going to make a polygon. And because we're making a polygon, I'm going to make, it's irregular, I'm going to make a P. So this is my polygon A, B, C, D, E, F, and don't forget to go back to the original point to close it up. It's your polygon A, B, C, D, E, F. All right, so that's our first step, construct an irregular polygon and label its vertices. Our second step is to find the image of that polygon under a 180-degree rotation. We need a point to rotate about. So I'm going to pick the center as 0, 0, just because it's a convenient, nice, simple point, but you could pick any point that you would like. And then to rotate, we need to come down here under transformations, and this is your rotate around a point. It's got a little angle. And it actually tells you when you click on it, select the object to rotate and the center point. So we're going to select our polygon, we're going to select our center point, and then we would like to rotate at 180 degrees. Now you can choose counterclockwise or clockwise, but for 180 degrees it doesn't matter because it's halfway around a circle, so it would be the same either way. And notice we get our image. So here is our pre-image A, B, C, D, E, F, and our post-image A prime, B prime, C prime, D prime, E prime, F prime, and each point corresponds to the other. So first I'm going to take this and color it. You can pick this little color. I'm going to turn him red just so we can talk about the blue and the red polygon. Sometimes you might have trouble seeing how D has been rotated around to get to D prime, and one way to visualize this that might help is to go choose a circle, go to the center, and then go click on point D. And it might help you to see that this D has actually followed this path of the circle and rotated around to D prime. And you could do this again with another point just to see how maybe B has rotated around the circle all the way to B prime. So sometimes it helps for visuals to be able to see that. I'm actually going to undo both these lovely circles just because we don't need them and they will complicate our picture. Okay, so far we have done these first two parts of the task. The third is create a mirror line and apply a reflection to the original polygon. So if I'm trying to get this blue polygon to be where this red polygon is, and we're doing a reflection, then I'm thinking I want a reflection line somewhere in this vicinity. So I'm going to go down here and click on my line tool, and I'd like the line to go through G, and this vicinity is this lovely y equals negative x line. So as we're looking at this, I would like to be, excuse me, there we go, right there. And so you get this lovely y equals negative x line. And if you want this line to not be as bold so that you can actually see what you're doing, you can come under here and you can either hide it or you can make it very light so that you can just see the line of reflection. A lot of times we like to do dashed lines for that, for reflection lines. Okay, our tool for this under transformation is right here. This is the reflection tool. We click the original and we click the line that we want to reflect it. Wow, you'll notice right away that this is not quite the same as the red, this image. So it's close. We got it in the same general vicinity, but the reason it's not exactly the same is because under reflections, the orientation is not preserved. It's a mirror image, so it does not stay in the same orientation. And as you look at this, one thing you can do is you can move this line and see, oh my goodness, I can get it almost there, but it's just not facing the same direction. You can see it right there. I can get D to the same spot, but that's it. So as I'm looking at this, it's just not quite hitting exactly this spot right here. So if we're to answer this question, is it possible for the image of the polygon after a rotation to correspond to the image of the same polygon under a reflection? Then our answer is, if it's under one reflection, the answer is no. So I'm going to come under text right here and type a polygon rotated 180 degrees does not correspond to a polygon under one reflection or reflected one time. Okay, and I'm going to move this up to here just so you've got it. Okay, so that's kind of our first answer. But as we're looking, further at this, I noticed that it's backwards and I kind of want to flip it over. And to me, when I hear the word flip, I think reflection again. So I'd like to take this and do a second reflection and see if I can get it to where, I'm still on text, to see if I can get it to where it's supposed to be. So one way to do that is to think about doing a second reflection line, okay? And so I can choose my line down here and choose the same point G and do a second reflection line anywhere I'd like to. It really doesn't matter. And again, I could dash that line to make it a little less obvious. I can even color it to show that it's a second reflection line in purple if we'd rather not dash it. And then if I go to my reflection tool down here under transformations, if I take this and the reflection line, oh, it's so close. And so now I can play. Now I can say, okay, what happens if I move that? Oh, look, I got it there. Let's see if you can look at my two reflection lines and see if you notice something special about them. It's kind of interesting. So let me move this one. Uh-oh, I lost it. I'm no longer at the same reflection. Let me move this one. Oh, now the image is the same as the other image. And notice my two lines again. So there's a few different ways to look at this. I can, again, flip it over this way, but look. I can sit there and play and try and try. Can I get them? Oh my goodness, can I get it to be so close? And look at that. So there are multiple ways to look at this, but the answer is if you do two reflections, you can end up getting the same image as a 180-degree rotation. But I hope you noticed as we were looking at it that the two reflections have to end up making 90 degrees. They have to be perpendicular lines. So thank you for joining me today to look at our transformations. We will be studying more about this in the future.